Hi, today we're going to be doing mixed function inequalities. We've done polynomials and rational functions where you have to use sign patterns, absolute values where you may or may not have to use a sign pattern or something, but just solve normally. These are going to be solved normally and maybe add a few things that you would have done with sign patterns or graphing. So if I had the problem like 2 times the square root of x plus 3 minus 4 is less than 6. Remember, as you do these problems, that a square root has a domain restriction. So make sure you're keeping your domain in mind when you're doing that. So begin the problem by thinking, what is my domain? And that would be x plus 3 is greater than or equal to 0. X is greater than or equal to negative 3. Now, solve your problem the normal way. So add 4. Divide by 2. Square both sides. So we keep the process the same that we had to begin with. And you get x is less than 25. Oh, it's 28. Sorry. Sorry, I don't know what I'm doing. Sorry. So subtract, and you get x is less than 22. But if I were to think about the graph of this picture, I know that I would have gone to the left 3 and down 4. And where is it equal to 6? So I can tell that when I work this particular problem that I've got a definite beginning and ending to this problem. So what you want to do is you want to make sure that you are going to take your domain I'm going to put it on a number line. And when I put the problem on a number line, I'm looking for where they are the same. So I need x is greater than or equal to negative 3. And I need x is less than 22. And I want the pieces that are the same. So the answer would be from negative 3 to 22. And making sure that I'm going to be watching the endpoints for my problem. Okay. So sometimes the domain is a little bit different. So if I have x squared minus 7 is less than or equal to 3. So as I begin working this problem and thinking about the domain, so x squared minus 7 is greater than or equal to 0. Factor this. Okay, put it on a number line so I know that I would have negative root 7, positive root 7. And now I'm going to think about the graphing part of this with the polynomial. So I know this is a parabola that would look like this. So the domain of this would be greater than or equal to 0 would be here, and it would be here. So now if I continue working this problem, I square both sides. So squaring both sides gets me x squared minus 7 is less than or equal to 9. Move the 9 over, x squared minus 7 minus 9 is less than or equal to 0. So x squared minus 16 is less than or equal to 0. X minus 4, x plus 4 is less than or equal to 0. And now I want to look at this on the number line. So if I were to graph this problem, closed on both ends, we have a parabola here, and we're putting these two together right there. So that answer to be anywhere between negative 4 and positive 4. So adding that to my number line from before, so I know that it goes from -4 to +4, closed on both ends of that, and where they are the same, here and here, is going to be the answer to my problem. So from -4 to -√7, they're closed at both ends, union √7 to 4. Again, it is all about watching what the domain is on the problems that you have. Okay, another thing that I might have to do with this would be the square root of x squared minus 3x minus 4 is greater than or equal to x minus 2. Okay, what's my domain going to be in the problem? So the domain would be x squared minus 3x minus 4 is greater than or equal to 0. Factor that, x minus 4, x plus 1 is greater than or equal to 0. So that would be from -1 to +4. Using a graph, greater than would be here and here. So that's a picture of the domain. Now I'm going to continue working this problem. So I'm going to square both sides. X squared minus 3x minus 4 is greater than or equal to x squared minus 4x plus 4. Your x squared 0 out. If I add 4x, I get x minus 4 is greater than or equal to 4. X is greater than or equal to 8. So if I put this on the number line with that, it is greater than or equal to 8. So then the answer is here, and the domain restriction doesn't change what my answer would be in the problem. So x is greater than or equal to 8, or from 8 to infinity. All right, another problem that has a domain restriction is logs. So if I have log base 5 of x minus 3 is less than 2. For this problem, and the difference between the one we just had is x minus 3 is greater than 0 this time. It is not equal to. So make sure that you remember that. So that gives me x is greater than 3. So I start with my problem at x is greater than 3. Now, work the problem, change to exponential form. So changing to exponential form would take this to this power is equal to that. And you need to make sure that you're keeping your x on the same side that you were on when you originally began the problem. So x minus 3 is less than 5 squared. X minus 3 is less than 25. X is less than 28. So I put 28 on my number line. It is less than 28, so it goes this direction. What they have is the same, is between 3 and 28. And again, you are looking at what your domain is and putting them both together. So log base 2 of 2x plus 8 is greater than or equal to 5. So find your domain. Always the first thing, or generally that helps. So 2x plus 8 is greater than 0. 2x is greater than -8. X is greater than -4. So starting what my number line would look like on this. If you choose to do sign patterns, you could do that too. I just think that using a number line is the easier part of that. Now begin working the problem. So this to this power is that. So 2x plus 8 is greater than or equal to 2 to the 5th power. So 2x plus 8 is greater than or equal to 32. 2x is greater than or equal to 24. x is greater than or equal to 12. So putting 12 on my number line, greater than 12 goes this way. So the answer is smaller than the restriction. So I just put from 12 to infinity. Right, and then just thinking about something that looks a little bit different in the process, which would be if I had 16 to the x minus 10 times 4 to the x plus 16 is greater than or equal to 0. So there is no domain restriction on this, but this is the one where we have to like change this problem. So 4 to the 2x minus 10 times 4 to the x plus 16 is greater than or equal to 0. And if I decide I'm going to play let u, so let u equal 4 to the x, remember we used this one. So that is u squared minus 10u plus 16 is greater than or equal to 0. U minus 8 times u minus 2 is greater than or equal to 0. 4 to the x minus 8 times 4 to the x minus 2 is greater than or equal to 0. Now, you're looking for the zeros on this particular problem. So if I'm looking for the zeros, I remember it is 4 to the x minus 8 equals 0. 4 to the x is equal to 8. 2 to the 2x is equal to 2 to the third. 2x equals 3, x equals 3 halves. We do not set this problem up as a equality when we're doing that, or an inequality. Always make it equal to 0. Again, looking for the intercepts. So 4 to the 8 minus 2 equals 0. 4 to the x equals 2. 2 to the 2x equals 2 to the first. 2x equals 1. X is equal to 1 half. So in doing that, I have my critical points for the problem. So now I want to think about what my answer is going to look like, because I have to deal with my inequalities. And I can do the problem two ways. I can either use sign patterns or I can use graphing. So in doing that problem, if I said I'm doing graphing, I would have 1 half, and I would have 3 halves. It can equal both of them. And this is a parabola here that I was doing. So I can put in a parabola, and we want greater than, so my answer would be here and here in this interval. Okay, if I did sign patterns, I could say I'm putting it into the 1 half power, 3 halves power, and check 4 to the x minus 8 and 4 to the x minus 2, just like we did before. If I said 0, 4 to the x is 4 to the 0 is 1 minus 8, so that's negative. 1 minus 2 is negative, so this section is positive. If I put in 1, 4 to the first is 4 minus 3, which is positive. And, 4 to the x minus 8 is 1 minus 8, which is negative. And this is 4 to the x, which is 4 minus 2, which is positive. So this section is negative. If I choose 2, 16 minus 8 is positive, positive, positive. So I get the same answer. So when I'm looking at a parabola, to me, it's easier if I'm just going to solve by graphing on that. So that would be the expectation for that particular piece of it. So I would say the answer then would be from negative infinity to 1 half closed union 3/2 to infinity. So just with parent functions, make sure that you're paying attention to what your details are with this, what are your domains, and make sure that you continue that whenever you're working through.